Good afternoon, everyone. My name is An, and today I would like to present about a study on the mechanical and sustainability performance of concrete incorporated with limestone powder, recycled ceramic aggregates, and coconut fibers. So there are some things you need to understand first before we dive into this study. So the traditional components of concrete include cement, natural aggregates, water, and steel reinforcement. And in this study, we're going to partly substitute cement with limestone powder. And from now on, I'm going to call it LSP. And LSP can increase the packing density of concrete and thus the quality of concrete. And then we're going to talk about aggregates, natural aggregates. Natural aggregates are divided into fine aggregates and coarse aggregates. And in this experiment, we're not going to do anything with the fine aggregate. We're only going to substitute the natural coarse aggregate with recycled ceramic coarse aggregates. And I'm going to call it CCA from now on. And CCA can improve the strength of concrete and improve the thermal resistance of concrete. And finally, we have coconut fibers. Coconut fibers are very ductile. It's tough, it's tensile, and therefore it's very crack resistant as it can pull the other components together. And this will completely replace steel reinforcement. Okay, so why does this study matter? Firstly, most research before, they only studied and discussed the individual effects of each of these new ingredients on the performance of concrete. And then the cement industry is not very eco-friendly, as it can take up to about 7 to 8% of the global CO2 emission. And then natural aggregates, we have to exploit from natural resources. And recently we've been running out of natural resources. And then finally, we have coconut waste. Coconut wastes are abundant in this world, luckily for us, and especially in tropical areas. And for these 4 reasons, there is a need for a substitution, for a sustainable substitution that also maintains the mechanical strength of concrete. So let's get to the methods. So to carry out this experiment, first we need to come up with a mix design. And let's look at this table here. The first column, we have the mix IDs from M1 to M5. And then we have the main components of concrete: binders, which includes OPC, which is the traditional cement, and LSP. Fine aggregate is just fine aggregate, natural fine aggregate. And then coarse aggregate, we have natural coarse aggregate, NCA, and then CCA. And finally, we have coconut fibers by percentage volume. And finally, we have water to binder ratio, and this ratio will remain constant throughout the experiment at 0.45. And one thing I would like you to be aware of here is M1. For M1, LSP is 0%, CCA is 0%, and coconut fibers is also 0%. And this is literally the traditional mix of concrete. And we're going to call this the control mix. And from M2 to M5, LSP, CCA will gradually increase from M2 to M5. And we will compare M2 to M5 with the control mix M1. And one more thing is that coconut fibers, they remain at a constant percentage too, at 0.2% from M2 to M5. And this experiment will be experimented with 3 types of specimens: cube, cylinder, and beam. Okay, so there are 7 main test methods. We have compressive strength, tensile strength, and flexural or bending strength tests. And these specimens, all of these specimens will be tested at 7 days, which is early strength, and 28 days, which is long-term strength of the specimens. And then we have durability tests, including water absorption test and mass loss test, thermal insulation test, And finally, we have ultrasonic pulse velocity, which is UPV test. And this test is used to estimate the density and thus the quality of the concrete. And in this picture here, as you can see, this is the UPV test. So basically, it is used to measure the velocity of the current traveling through a block of concrete. And the higher the velocity, the lower the porosity. And that is a good sign that we are looking forward to. Okay, so moving on to the results. For mechanical strengths, the first chart is the compressive strength. And as you can see here, for compressive strength, M3 and M4, both at 7 days and 28 days, demonstrate the highest compressive strength. Especially for 28 days, M3 and M4 are both over 40 megapascals. And mind you that the normal range of compressive strength for normal concrete is from 20 to 40 megapascals. And it already far exceeded the normal range for compressive strength. So that is good. And then tensile and flexural strength, they both demonstrate the same kind of pattern, where M3 demonstrate the highest values at 7 days and 28 days. And as you can see here, higher early strength by 15.3% and higher long-term tensile strength by 22.7%. And same goes for flexural strength. And then we have water absorption results. Water absorption, it increases with higher substitution percentage due to increasing in porosity. However, the increase only ranges from 0.21% to 0.76%. So that is still acceptable. And then mass loss, the mass losses of M2 to M5 are all lower than the control mix M1 in all types of specimens. And this is because LSP can fill into like the micro voids of concrete, and coconut fiber, it is very crack resistant. And moreover, like because it is crack resistant, less water can get into the inside the concrete, and that's why like the degradation will be less likely to occur. And then we have thermal insulation, as you can see here for cube, cylinder, and beams. The blue color is cool temperature, green is moderate temperature, and red is high temperature. And as you can see here, all specimens, most of them are quite successful in separating itself thermally from the surrounding environments. So, in other words, it's very well thermal insulated. Okay, so lastly we have UPV results. As you can see in this chart, in cube, cylinder, and beam specimens, all of the velocities, they increase with the increasing percentage of substitution of LSP and CCA. And the normal UPV value for a very good concrete is 4,000 meters per second, or 0.0045 meters per microsecond. And in this chart here, for example, in cube M5, it is around 20 meters per microsecond. This is so much higher than 0.0045 meters per microsecond. So this is like a very good quality concrete. And that's why we can conclude that M3, 10% LSP and 20% CCA, and M4, 15% LSP and 30% CCA, both of them at 0.2% coconut fibers, demonstrate the most improvement out of all mixed IDs. And we can also conclude that the incorporation of LSP, CCA, and coconut fibers in reinforced concrete improves not only the mechanical strength, but also the sustainability of concrete. Okay, so thank you for listening.